Now we want to solve equations and inequalities. First, we have the method of opposites that we use to solve linear equations. We remove parentheses using the distributive property, combine similar terms on each side of the equation, move all letters to the left side of the equation, move all numbers to the right side of the equation, and then finally multiply or divide to isolate x. Many times we can skip some of these steps. Let's begin by looking at the equation 4x minus 27 equals 5. We don't have any parentheses. We don't have any terms. We don't have several x terms on the left or number terms on the right. So we begin by moving all letters to the left side of the equation. And here, all the letters are there. There are no letters on the right. So we would move all numbers to the right side. So we do that by, since this is the method of opposites, we're the opposite of minus 27, so we're going to add 27 to both sides of the equation. As long as we do the same thing to both sides, we're allowed to do whatever we like. So 4x, these cancel out, we get a 0. The equal sign falls straight down. 5 plus 27 is 32. Now we've moved all the numbers to the right. We want to multiply or divide to isolate x. Here we have 4 times x. The opposite of multiplying by 4 is dividing by 4, so we divide both sides by 4. So we get 1x, which is usually just written x. 32 divided by 4 is 8. So our solution is x equals 8. By the way, we can always check by substituting our answer into the original equation. If we put an 8 here, 4 times 8 is 32, minus 27 gives us 5. So we know, as a matter of fact, this is correct. This is a valuable tool to be able to check your work. Let's look at 3/4 x plus 18 equals negative 6. We don't panic because we see a fraction. We can skip steps 1, 2, and 3, but let's look at step 4. Move all numbers to the right. How do you get rid of the plus 18? We do the opposite, minus 18. Notice the name of the method is opposites. So we minus 18 from the right-hand side as well. Please notice that you always have to do something to the left-hand side of the equation and the right-hand side both. These drop out, you get 0. So we have 3/4 x equals negative 6 minus 18. Notice they're both negative, so we get negative 24. Now we're going to multiply or divide to isolate x. The opposite of multiplying by 3/4 is dividing by 3/4, but you can also multiply by the reciprocal. So let's multiply both sides by the reciprocal, 4/3. The 3's cancel the 4's, so we're left with 1x or x. Here, the 3 cancels with negative 24, so we get negative 8, and negative 8 times 4 gives us negative 32. X equals negative 32 will be our solution here. Let's try something a little more complicated. Once again, we can skip steps 1 and 2, but step 3, move all letters to the left. So in this case, notice we have 7x on the left and 2x on the right. So we move it over by, let's minus 2x on both sides of the equation. Our equal sign comes straight down. Make sure that you're combining things from each side. 7x's minus 2x's makes 5x's. Our subtract 4 just comes down. 2x minus 2x cancels out to 0, so we have 46. And now we're similar to the problem above. We want to get x by itself by, first let's get rid of the minus 4, so we plus 4 to both sides. Our equal comes down, this comes to 0, we have 5x. 46 plus 4 is 50. The opposite of multiplying by 5 is dividing by 5. So x equals 10 will be our solution. Let's look at an example with parentheses. When we see the parentheses, we want to get rid of those using the distributive property. So we go 7 times the x gives us 7x. 7 times the 5 plus 35. This is a very common mistake to forget the 7 times the 5. Minus 3x. Everything else just falls straight down. Now before we go on, notice that we have a 7x and a minus 3x on the left-hand side. We can put those together. 7 of them minus 3 of them is 4 of them. Please notice when they're on the same side of the equation, you simply do the operation. When you go from one side to the other, you do the opposite. So we have 4x plus 35 equals 4x plus 35. Next, we want to move the x's to the left. So we minus 4x from both sides. Minus 4x from both sides. So we get 0, 35 equals 35. Something really strange has happened here. Notice that all the letters have disappeared. If all the variables, the letters x's, disappear and you're left with a true equation, we have what's known as an identity. So the answer to this particular equation, it's actually an identity. No matter what you put it on the left-hand side of the equation, if you put the same thing on the right, these two will always be exactly the same. Let's look at an example that has fractions in it. At first, this looks very challenging, but the trick is to get rid of all the fractions. Notice we have a denominator of 4 and 3, so our least common denominator then would be 12. So what we're going to do is multiply everything through by 12. 12 times this fraction, 12 times this number, and 12 times this. Now what's going to happen, the 12 and the 4 cancel and you're left with the 3. Let's distribute the 3 times each of these. Gives us 3 times 3x is 9x, 3 times 1 is 3. Negative 12 times 2 is negative 24. 12 times this fraction, the 12 and the 3 cancel, so you're left with a 4. 4 times x is 4x. Applying the distributive property again, plus 4. Now on the left-hand side, we have two number terms. We have 9x. 3 minus 24 is negative 21. 4x plus 4. Now, we have letters on the left and the right, so we want to get all the letters to the left-hand side. So let's do that by minusing 4x from both sides. So we're left with 5x minus 21. These drop out and we get 0. We're left with 4. Let's add 21 to both sides of the equation. So we have 5x. The 21's cancel. You're left with 25. 5x equals 25. The opposite of multiplying by 5 is dividing by 5. So x equals 5. Remembering that we could put 5 back into this in our calculator and double check to make sure the two sides are the same. Finally, what happens if we have an inequality, less than, or equal to? Solving an inequality, we're going to use the method of opposites from above, exactly the same. However, if we multiply or divide by a negative number, we must reverse the direction of our symbol. So let's look at a couple of examples. Here we have 5 minus 6x less than 41. Just like before, let's get rid of the number term from the left and move it over to the right. So we're left with 0 minus 6x less than 41 minus 5 gives us 36. Now the opposite of multiplying by negative 6 is divide, so let's multiply both sides by negative 6. So we have x, 36 divided by negative 6 is negative 6. However, notice we have divided by a negative number, therefore the less than symbol becomes a greater than symbol. Notice that you have to write the entire expression here. You just can't write negative 6. You must have x greater than negative 6. On a number line, if we're going to graph this, negative 6 is our key number. X greater than negative 6. Since the x is on the left, this points, so the direction of the arrow means it goes to the right. Notice numbers like 2 and 10 and 8 are all greater than negative 6. Because it does not have a line underneath, we have this as open. So this would be the graph that goes with our solution. Finally, let's solve this inequality. Again, we get rid of the parentheses by applying the distributive property. 4 times x is 4x. 4 times 3 is 12, greater than or equal to 9. Let's subtract 12 from both sides of the equation, inequality. 4x is greater than or equal to negative 3. Let's divide through by 4. So we have x is greater than or equal to negative 3/4. Now notice there's a negative in the problem, but we divided by a positive, so we do not change the inequality sign unless we're multiplying or dividing by a negative. So our solution is x greater than or equal to negative 3/4. So again, if we put a number line so we can graph this, negative 3/4 is the key value. Since it's greater, it goes to the right, and it goes all the way up to 1,000,000, etc. Now because it has the line here, we color this in.